Star, a celestial object that has served as a stable reference point for centuries. Astronomers around the world, including well-known science communicators like Neil deGrasse Tyson, have raised concerns about the possibility that this guiding light may be undergoing a fundamental shift that could alter our understanding of the sky and disrupt some of the most basic astronomical measurements and navigational practices we have long relied upon. Polaris, also known as the North Star, holds a special place in both the history of science and the human imagination. Its nearly fixed position above Earth's northern axis has made it an indispensable tool for celestial navigation. Mariners traversing vast oceans and travelers crossing uncharted lands have depended on its steady glow to orient themselves, using its position in the constellation Ursa Minor as a reliable marker. Appearing to the naked eye as a moderately bright yellow-white point in the sky, Polaris is in fact a complex triple star system consisting of Polaris AA, Polaris UB, and a more distant companion, Polaris B. The gravitational interactions among these three bodies influence their orbits, brightness, and subtle pulsation cycles. Small variations in these interactions can cause measurable changes in the star's luminosity and behavior, though the precise mechanics remain only partially understood. Situated roughly 323 light-years from Earth, the light we see from Polaris today actually left the star over 3 centuries ago. This enormous distance creates a built-in temporal gap in our observations. If Polaris were to undergo a dramatic event such as a supernova today, its effects and brilliant light would not reach us for another 323 years. This delay introduces a fascinating and unsettling uncertainty to our view of the universe. Some scientists even speculate, though cautiously, that Polaris may already have undergone some catastrophic transformation, but the evidence has yet to arrive. Such conjecture underscores the limits of our direct knowledge of stellar evolution as it unfolds in real time, leaving open the possibility that the star we depend on so deeply for orientation and symbolism might already be dramatically different from how it appears. Throughout human history, Polaris has been revered not only for its practical utility, but also for its symbolic significance. Its unwavering presence in the northern sky has made it a cornerstone for navigation and a cultural icon of stability and guidance. Ancient mariners used Polaris to chart their journeys with precision long before the invention of compasses or GPS. Its steady glow served as a cosmic anchor in the swirling sea of stars, embodying reliability in a universe that otherwise seemed chaotic and unpredictable. Civilizations around the world wove Polaris into their mythologies and traditions, elevating it to a symbol of constancy in a changing world. But recently, this reputation for steadfastness has been challenged by subtle but scientifically significant anomalies in the star's behavior. Astronomers have detected changes in Polaris' pulsation cycles, rhythmic patterns of dimming and brightening that had once been remarkably stable. Instead of maintaining its predictable tempo, Polaris has exhibited erratic variations, prompting intense study and debate within the astronomical community. These irregularities suggest that the star may be nearing the end of its life cycle, entering the final stages of stellar evolution. One particularly notable change has been the progressive lengthening of its pulsation period, which has increased by about 4.5 seconds. Seemingly a small shift, but one with important implications for understanding its internal structure and future evolution. The source of these changes may lie in the gravitational dynamics within its triple star system or in atmospheric fluctuations intrinsic to the star itself. However, some astronomers see these anomalies as harbingers of a far more dramatic fate: the possibility that Polaris is on the verge of exploding in a supernova. Comparisons have been drawn between Polaris and Betelgeuse, the prominent red supergiant in the constellation Orion. Betelgeuse too has shown mysterious and dramatic variations in brightness, including a much publicized period of deep dimming in 2019 and 2020 that spurred widespread speculation about an imminent supernova. While Betelgeuse has received significant attention from NASA and other organizations monitoring its behavior closely, Polaris changes have been subtler and have therefore escaped the same level of public scrutiny. Nevertheless, the parallels are striking. Both stars are in advanced evolutionary stages. Both have exhibited unanticipated variability that challenges existing models of stellar behavior, and both raise fundamental questions about how massive stars die and how these deaths reshape their surrounding cosmic environments. In the case of Polaris, should it eventually go supernova, the consequences for our night sky would be profound. Despite its distance ensuring Earth's safety from any harmful radiation, the visual spectacle would be awe-inspiring. Polaris could become so luminous as to rival or even surpass the brightness of the Moon, casting its brilliant light across the sky for weeks or months. Such an event would transform familiar constellations like Ursa Minor, reconfiguring our sense of the sky's order and permanence. Beyond the spectacle, the cultural and symbolic loss would be equally significant. For centuries, Polaris has been more than just a navigational aid. It has been a touchstone for human imagination, a beacon of certainty in an otherwise shifting world. Its disappearance or dramatic transformation would mark the end of an era. Mariners and explorers of the past relied on its fixed position to navigate the globe, a role that persisted right up until the advent of modern technologies like GPS. Even today, its importance as a cultural symbol of guidance and reliability endures. A supernova would not just erase the stable point of reference. It would remind us of the impermanence that underlies even the most seemingly immutable features of our universe. This evolving narrative of Polaris invites us to reflect on the very nature of cosmic time and distance. The 323 light-years separating us from the star means that what we see is always a glimpse of its past, a snapshot frozen centuries ago. If Polaris has already exploded, the news is quite literally still in transit. This temporal disconnect underscores both the wonder and the challenge of astronomy to understand events as they were, as they are, and as they will be, even when our only direct evidence comes from ancient light. It also illustrates the patience and humility required in the study of the cosmos. Astronomers continue to monitor Polaris carefully, studying every subtle shift in brightness, every change in pulsation period, every gravitational quirk within its triple system, hoping to unravel the story of its future from the clues available today. While some researchers attribute Polaris' changing behavior to natural variations within its system, perhaps complex, but ultimately non-catastrophic. Others argue that these irregularities are clear indicators of an impending explosive end. The possibility of losing Polaris as our steadfast North Star is therefore a double-edged prospect. On one hand, it would disrupt traditions of navigation and cultural storytelling that have endured for millennia. On the other, it would provide an unprecedented opportunity to study the universe's dynamic processes in action. It would highlight the universe's capacity for renewal, reminding us that even in destruction, there is creation, as the elements dispersed by a supernova go on to form new stars, planets, and perhaps even life elsewhere in the galaxy. Moreover, the unfolding story of Polaris speaks to the interconnectedness of time, space, and human curiosity. It reveals how intimately our lives are tied to cosmic events playing out across unimaginable distances and time scales. Our ancestors watched Polaris and trusted its constancy. Today, we watch it with scientific instruments, seeking to decode the subtle warnings it may be giving us about its future. In doing so, we confront the transience of even the most enduring celestial markers. This confrontation is not only a scientific journey, but also a deeply human one, forcing us to reckon with change, uncertainty, and our own place in an evolving universe. Ultimately, whatever Polaris' fate may be, whether it continues to shine steadily for centuries more or one day bursts into brilliance and fades away, it will remain a symbol of our collective quest to understand the cosmos. Its story is our story, one of exploration, of confronting the unknown, of finding meaning and guidance in the vast and often unpredictable universe that surrounds us. And as we continue to study its behavior, we are reminded of the delicate balance between constancy and change that defines not only the stars but life itself. This evolving relationship with Polaris also highlights the way science itself changes over time, reflecting our growing ability to observe, measure, and interpret the cosmos. Early astronomers knew Polaris as a nearly fixed point of light, a gift of orientation and certainty. But with the advent of modern telescopes, spectroscopy, and precise photometric measurements, we began to see that even this fixed star is dynamic and complex. We learned it is not a single star, but a system of multiple stars bound in gravitational interaction. Their subtle tugs and exchanges shaping the very light that reaches our eyes. We discovered its pulsations, its slight variations in brightness and period, and even the minute changes in its position relative to distant background stars. Each of these offering a clue to the hidden processes unfolding within. Today, the study of Polaris is not merely an exercise in cataloging a celestial object. It is a window into fundamental questions about stellar evolution, mass loss, and the ultimate fates of giant stars. It reminds us that every point of light in the night sky has its own history, a drama unfolding over millions or billions of years. Polaris' behavior may offer unique insights into the way massive stars transition from stable fusion phases to unstable variable states before their final catastrophic demise. Its peculiar pulsation shifts might reveal details about internal structure, convection, or even mass transfer among companions in its star system. For scientists, these are precious data points, opportunities to test and refine models of stellar physics that will apply to countless other stars across the galaxy. At the same time, The cultural resonance of Polaris cannot be ignored. In a world where advanced technologies guide our paths, where satellites beam positioning data to smartphones with pinpoint accuracy, the idea of finding one's way by the stars may seem quaint or romantic. Yet, for millennia, this was a vital skill. Entire cultures developed sophisticated methods of navigation based on the night sky, and Polaris, so steady and reliable, became a universal touchstone in the northern hemisphere. It was the star that didn't drift or wander, a constant in an ever-shifting dome of heavens. Mariners crossing the Atlantic or the Arctic, nomads traversing deserts, all found reassurance in its unwavering presence. Even today, its symbolism lingers in literature, poetry, and our collective imagination as an emblem of guidance, faithfulness, and truth. The possibility that this enduring guide might change or even vanish in a blaze of stellar death forces us to confront the reality that nothing in the universe is truly permanent. The loss of Polaris as the North Star would not just be a scientific event to be studied. It would be an emotional and cultural moment.